engagement. This is the work which I did for my PhD research in urban science, and I wrapped it up in a book called Democracy Studio. So I will start with a few words about myself. Who am I? Yeah, my name is Julien Carbonnell. I'm born in and grew up in the south of France, yeah, I've been doing my PhD in urban science. I'm at the end of it right now, so you can add me on LinkedIn on my usual name. That would be great. And otherwise, about my pathway, I started to with psychology studies, which I graduated in 2008, and then I wanted to understand better how was working enterprises, and so yeah, I joined a real estate development company in the south of France from 2009 to 2018. And I've been early attracted by the co-designing with neighboring inhabitants from 2011. So I tried many different stuff with that objective from various perspectives. I've been engaging in some non-profits. We've been co-creating a think tank in my hometown. And also try different startup projects. And at one point, I wanted to strengthen the scientific establishments of my field observations. And so I started an academic research on citizen engagement in smart city in 2018. It is about to end now this year. With Democracy Studio, I took the turn of the data analysis and the computational models. All these are written in Python language, which I learned some months ago, and I've been practicing so far. So yeah, that's about the PhD research. So it is on citizen engagement in smart city, and I'm doing this research with comparative cultural studies. So I wanted to compare very different cultural backgrounds in Asia, Middle East, and Eastern Baltic. So I chose the three case studies, which are Taipei City in Taiwan, Tel Aviv in Israel, and Tallinn in Estonia. Those three cities are famous startup hubs and advanced smart cities, and they are also vibrant democracies of let's say, reasonable demographic size. So that was the perfect, let's say, combination to study these three case studies. And so my method of research has been to duplicate the same protocol in those three studies. It's based on internet-based research with data collection mostly on social networks, but also more broadly on the web to get information on my cities. Then I'm also spreading surveys indirect to inhabitants by using Facebook groups or direct messaging on messaging apps, and also meeting people in different forums and events. I've been organizing some collaborative workshops to proof test my first insights with locals. Of course, when the pandemic started, so I haven't been able to pursue that way, but still it was a funny way to have some feedbacks from inhabitants in Taiwan. And then I've done one-to-one interviews of local experts. And so this basically is a triangulation process of sources of data, which tends to increase the validity of the insights. And as you can see, you have varying levels of expertise like from the social media analysis, for example, the level of expertise is very low, but it goes higher when you rise in these data sources, and it's at the top of the expertise level when you go in one-to-one interview with key stakeholders. Then the quantity, of course, goes down. And yeah, it's way more easy to collect a lot of data on the web rather than doing one-to-one interviews. So I just want to say something. I published the sources on the last line. So on most slides, you will see, if you want more information about what is written on the slide, you can just type it in your web browser, and all these studies writings have been published on Medium, so you will find it with the title I give you on the bottom. So yeah, just a few background concepts. So contemporary democracy are usually considered as a mix of apathetic moods and demanding outsiders. I'm using the concept of post-democracy to designate a collapse in the trust of public agents and media. And so at the same time, most nation states worldwide adopted democracy, but the early adopters, which are notably Western Europe, Japan, USA, and other industrialized countries, they became less optimistic on the future of their democracies. So there is this kind of citizen crisis, which both refer to a political apathy and a mistrust from the voters. We have two, let's say, explanations to that state. It's both the loss of traditional collectives like the family, the social class, and nation unity, which are a bit weakened in those contemporary states, and the globalization, which propose new networks of solidarity outside of national interest. So there are probably other reasons, but yeah, these are two simple ones. And so what we see as a phenomena appearing on the medias, notably the social medias, which are less regulated than the traditional one, is what we call astroturfing. The astroturfing denounce an appropriation of a fake citizen identity in media to influence the public. And so in this context, we tend to think that the upcoming citizen, which were born in a world where politics are taunted for not solving issues, they will rather engage politically aside of official electives by petitions, neighborhood projects, or direct activism. And it creates kind of distant citizens which have a good capacity to understand the society issues and play their role when it's needed. Voting, for example, is not anymore considered as a duty to society in some countries. France is one of it. We have a lot of abstention increase in our country, and I assume it's kind of the same in many other places of the world. So on the urban planning side, the smart city is a new approach which consists mainly in using data to improve cities and having a collaborative management of all stakeholders. So the later progress of communication and information technology changed how we define life, reality, and human being. Humans are now considered as interconnected informational organisms which share a global socio-technical system with both biological agents and technical artifacts, and the unique world to live in this hybrid between online and offline experiences, which forms a single reality. So the smart city movement started with tech on infrastructure in the 90s, but now it's much more citizen-centric because the smartphones have become the key to cities, pushing information into residents' hands. And the electives and the public services can take an instant pulse of public opinion by using these devices. So we usually explain how two forces are driving our urban futures by this concept, the tech push and market pull. So basically, these two forces explain that a new product is ushered on the market regardless of public governance. So it's what we call the tech push, and the market pull, where we can observe a market civil society deal, which is formed directly in between providers and consumers as a new kind of collective regulation on what will be our future. So that's an overview of what are data collaboratives on cities. So basically, at the center, we have a kind of cloud with data management softwares and computing environment. So all the hardware which supports all the data supply and value-added services based on data. And this cloud is usually filled by many different sources, such as civil IoT, for example. You can have the regular information of cities are air quality, earthquake, water resource. The government also adds data about policies, and you also have non-governmental stakeholders publishing other kind of data on these collectives. And so research institutes and industry are developing analytic models and algorithms, and which some of them are open source and are shared on this cloud. So this is exactly what we will be jumping in now. The analytic models and algorithms which I built for my research, it's both of machine learning and agent-based model, and everything has been coded in Python. So yeah, in the machine learning, I created three models. Sorry, we have the ranking model for citizen engagement in smart city. Then we have a predictive model of public opinion, which is based on Twitter mining, and a classifying of citizen engagement in smart cities from graphs, which means from topological social networks. And then I've been doing two agent-based models, which are computer simulations to make inferences outside of our datasets. And so these two agent-based models are the first one simulating the formation of public opinion by citizen engagement, and a second one simulating collective dynamics of decision-making by multi-stakeholders.
Hey, Julien.
Yeah.
Could you please elaborate what does an agent-based model mean?
Yeah, sure. So,
thank you so much.
Agent-based model, it used to be called multi-agent models. So it's a form of systemic artificial intelligence. So it's an AI which is shared on intelligent agents that will interact. So basically, we are modeling agent-based models to observe the reaction of complex adaptive systems. So, for example, if you want to make some observation on, it's used both in biology but also in social studies. Imagine that you want to predict the movements or the behavior of birds flying together, and so yeah, you will distribute artificial intelligence to each bird of your system, and they will have some random parameters and some parameters that are coded genetically, and so you let them run on your computer, and so you simulate this bird fly, and at the same time you collect data on your intelligent agents. So it's a way to make some more data analysis on complex systems.
Mm-hmm. Thank you.
You're welcome. So the first model I will present you is a ranking model for citizen engagement. And basically the purpose is to rank cities on their citizen engagement dynamic detected by a survey study. It has four steps. The first one consists in data cleaning, which I did with the pandas and NumPy libraries. Basically, it's cleaning the null values, outsiders to it's cleaning a bit the data types, and then I make a split between categorical and numerical variables. So then I can process the second step, which is statistical analysis. I will show you some EDA correlation analysis and regression analysis. The EDA means exploratory data analysis. It's kind of the first step you usually do with your data. It's the more superficial one that you can see with the eyes. In this, I'm using those two libraries, which are called Seaborn and Matplotlib. And then I'm deploying four different ranking models from the scikit-learn library. This machine model to classify, machine learning models to classify, sorry. So I'm comparing the performance of four different models, which we will detail later. And at the end, I'm finishing my study with some inferential statistics. So basically, it's probabilities to test the hypothesis. And this is done with the library SciPy, but we won't say too much today. So, yeah, the data set is composed of 366 survey respondents. I had 122 in each of my 3 case study cities, and it's composed of 18 questions, which I am turning into 45 variables. So the analysis process is that one. I start with an exploratory data analysis, and so basically these are simple statistical representations that you can see here. For example, on this pie chart, I have an engagement frequency agreed over all my 3 cities. And so we can easily see, for example, that if you have, for example, like 1 hour a week, so that was the answer where my respondents were saying how much they agreed to engage in their city, in decision making for their city. And so the feedback is quite good, quite enthusiastic, to be honest, because we have more than 3 or 4 people that wish to engage more than 1 hour a month. If you check here, we have 1 hour a day, 1 hour a week in blue, and 1 hour a month in orange. So yeah, and here you have the engagement feeling by city, so you can directly visually compare, like that. For example, Taipei, Tallinn, and Tel Aviv, they don't exactly have the same distribution of the engagement feeling. So for example, people feeling really not engaged are mostly in Tallinn, but then yeah, you see the shape of the curve is a bit different. In Taipei, it's much more regulated, for example. So that's what exploratory data analysis are. It's something more, let's say, overall superficial with the eyes. Then when we want to dig into more correlation between variables, we usually create what is called a correlation matrix. And so here you can see you have all the variables which are integrated in your matrix, and you can detect which are more correlated to each other. So basically, you can see that when some score of correlation is above 0.5 or under 0.5, it's considered to be a positive correlation or a negative correlation. And then we can see here, for example, that there is a kind of cluster of positive correlation between those variables here. We also have other ones here, so we can detect it quite easily. And then when you have identified interesting correlation between variables, then usually you switch to a linear regression analysis, which shows you much more in detail what is the relationship between your two variables. And here, for example, I'm showing you the relationship between opinion sharing in a city and the engagement feeling. And so we clearly see that the most people feel engaged, the more they tend to share their opinion easily in the public space. Then you have some numbers like attesting the intensity of the relationship. Okay, so different hypothesis has been validated by this first study. I've been lightening that the citizens feeling the most engaged want to engage more. So it's a kind of mindset to engage. Also that the citizens engaging more share their opinion more easily in public. And these citizens sharing opinion more easily also change it more often in contact to others. So it proves a kind of openness of mind. So I cannot say from my study that, for example, someone who has a very strong opinion will try to get in contact with the others because he don't want to change his opinion, he just want to convince others. So that's not what happened, basically. People who engage more are more open to the opinion of others and can change, adjust their opinion in contact with others' opinion. And so I also identified that the engaged citizens usually use more sources of information to shape their opinion. And so I've been integrating these variables into machine learning to rank models. The four different ones are logistic regression, a KNN classifier, and multi-layer perceptron, and support vector machines. And so I'm using those four machine learning models to detect highly engaged citizens from my data set. So as you can see, the same data set that is processed into four different models, and then I am evaluating the performance of this classifier task. And as we can see here on this graph first, you can see that the green line has better prediction scores. It has lower error scores. And so basically the multi-layer perceptron is the one achieving the best performance. It has a performance in predicting, detecting the highly engaged citizen that's above 95%. As you can see, there are no false negatives and they are less than 5% of false positives. So this data analysis has been on survey, has been used to make the first computer simulation. So now you will see what is an agent-based model. Basically, this one is called the Citizen Engagement ADM. And the purpose of this model is to experiment the formation of public opinion in a population influenced by highly engaged citizens. So as you can see, I will show you a video, but first I would like to tell you, as you can see, these are agents that will interact each other, trying to influence their peers. And so you will see the rules of behavior for my agents are, they will look for a peer to talk to, then they will battle for opinion. They will gain an engagement score by interacting, and they will gain social status by winning an argument. So both engagement and social status increase their power of influence. It means that it's giving them a better vision so they can reach people from far, and it gives them a better speed so they can move in the model more easily to get in touch with more people. So let's try it here. So as you can see, that's the interface of my model. You can here choose the number of citizens that you want at your setup. And you can also choose the initial percentage of highly engaged. So as you can see, the highly engaged citizens are taller than the non-highly engaged ones. I will make a simulation which will be like usual rates is about like 8-9% of highly engaged and 100 citizens. And so I do a setup and I will start running it. So the agents are moving. I will maybe speed it up a bit. And you see, so they get in touch with one of each other. You can see some of them are peering, yeah. And I will make a detail on one citizen. So we will follow him. So I don't know exactly what place it. I want you to see the graph. So yeah, it will be there in the corner. And okay. So as you can see, the agents are interacting. At the moment, they don't have any facilities, so they don't gain engagement score and they don't gain social status. They are just interacting like that and changing the color. So the gray ones are neutral agents. They don't have an opinion. The red one have negative opinion and the blue ones have a positive opinion. And we can follow the public opinion in the charts on the right and the numbers of each of them in the boxes top right.
Hey, Julian.
Yeah.
Quick question. So in this simulation,
Yeah.
you have the physical representation, physical like movement of agents or simulated people based on their social media engagement?
No, the social media will come afterward. On this first simulation, I'm only using the data which comes from the survey study. And so we are not here in the context of social media interaction. We are more in the context of a city where people are just getting in touch one with each other to form the opinion on some topic.
I see. Okay. So community getting together, things like that.
Yeah. We can imagine they are working in public space or in an event, for example, and they are talking to each other. And then we can see that it takes so with no facilities, it takes significant time, let's say 5,300 ticks for an opinion to form. And then so I'm setting the facilities on. So now by interacting, my agents will win some engagement points and social status, which will confer them more ease, I mean a better, an ease of influence power.
I see. Thank you.
You see that at some point, if the agents do not interact, he will become slower again. So he can lose his facilities. And it's the same for the social status. When he wins an argument, he wins social status. But if he loses an argument because the other one has the sharpest opinion, so the agent will lose some social status. So basically, it's a battle for influence on opinion.
Mm-hmm. So a quick time check. We are at 36 minutes.
Oh yeah, already.
Yeah.
Okay.
Yeah, this is a huge topic.
So yeah, as we see, well, what I wanted to show you on this simulation is that the emerging patterns are saying that after some time, an opinion, it can be positive or negative, takes the advantage, and it turns the whole population to its side. So there is a dominant opinion which is susceptible to the slight unbalance at the setup. It means if you have 1, 2, 3, more positive or negative opinion, it can really change the results. But what we can see then is that the engagement score and the social status facilities can reverse an imbalance. And so as we can see it here, oh, sorry, I should make it bigger, I think. Yeah. And so as we can see here, it takes a certain time without facility, but it takes half the time when we have the facilities in forming an opinion. And so I can see there on the graph that there is an ideal proportion of citizen engagement, which significantly boosts the formation of public opinion. And with the social status reward, it makes it more predictable somewhat, this formation of public opinion. So as we maybe don't have that much time, I'm sorry, I didn't expect it will take so long. So maybe I will go a bit quick on these ones to show you the final presentation. So this is the second machine learning model, which has been done with natural language processing on Twitter mining. So basically, I have collected 110,000 tweets in 109 smart cities in the world. It means like a bit more than 19 million of words, sorry. And so this words has been cleaned first, and then I have extracted them by sentiment analysis algorithm. I have extracted the sentiment attached to each tweet. And basically, this sentiment allows us to detect a subjectivity score on each tweet. And this subjectivity can be predicted from the content of the tweet. So it means basically that it's doable to use a subjectivity put in a tweet as a basis to rank citizen engagement. I'm going a bit fast, but it's the same. I mean, it's the same logic that the one we just see. It's just different data which are collected on Twitter, and then different variables which are mostly a subjectivity and the sentiment score which are used. Then I've been doing some graph-based machine learning. So you can see this is more based on the topological attributes of networks. So who is connected with who? And so basically, yeah, it asks for some data transformation. So you have this kind of raw tweet data, and you create it, you assemble it in a 3D network like that, and then you extract features on the nodes, on the edges, and on the network as an ensemble. And so that's, for example, yeah, a video of what is a force-directed graph on Taipei City. So you can see here how the networks are formed. I will add the label. So you can see here we have the labels, and so we see that we have very like strong nodes. For example, this is the Taiwan News, it's the main newspaper, and so of course it's very much more connected to a lot of other ones. And then so I've been using, yes.
Hey, Julien. Yeah, a couple of questions in the audience. They're curious to know what is the platform that you used to create your simulations?
So
yeah.
this one, for the simulation, the first one, it was net logo. So basically, I told you I did all my work in Python, but it's not true because there is a nest of net logo stuff. Yeah, I've been using Python for IBM later. So basically, it could have been done with Python as well, with different framework. And so I would like I'm jumping on the opportunity to show you the last one, the last simulation, which has been done with Python. And so basically this one is based on social networks. It aims to experiment the power of influence of different stakeholder categories. So from the data analysis, which I've done with the previous machine learning, I collected some attributes and I set different scores to different stakeholders category. I will show it with the video, you will understand. And so it's kind of the same rules of behavior. It means that, yeah, we can, so here we have simulation of networks. We can, for example, check the number of nodes that we want to have in our network. See, and here we have a bigger network, and we can also evaluate the average node degree, which makes the network more or less dense and connected. Yes, even more than that. It's a very dense network, which affects, of course, the opinion formation. And so you can follow nodes one by one. They have an ID and opinion. Most of them are assigned an initial opinion, which is neutral. And then we have like 6 stakeholder categories, which are public sector. For example, I will give them a positive opinion toward a random topic. Corporate companies will follow the same positive opinion. And then the startup will have a negative one. Yeah, as the academics and the civil society, while the media are on the side of public sector and corporate companies. And so then you are simulating the network. You see that some of them have a color, and they will try to influence the neighboring nodes. And so then you see how the opinion spreads on social networks based on different attributes of nodes. So that's the last simulation which has been built with Python, and it integrates all the data of my research. So I will say that it's the real final model of my research. So yeah, as you can see, it's evolving like that, and at one point, one opinion takes the majority. But still it remains neutral ones, and the minority opinion remains as well. So yeah, that's it. Mostly all the details are on this book, which is published on Amazon, and you also have online resource. So I'm publishing regularly videos on my YouTube channel, and you have access to my GitHub code at that name, Democracy Studio. I will be very glad to give you some more answers if you have. I think you have some in this tool. So yeah.
Yeah. Thank you so much, Julien. We have another question. Regarding any biases creeping into the data, are we considering different demographics in the data yet, or is the result specific to each city in your research?
So yes, exactly. So the insights are validated on my case studies, and I have conducted some inferential statistics to be able to extend my my conclusion to other cities. So it appears that on some models, the size of the samples. I mean, it's called an ANOVA, so it's an analysis of variances, and basically my three samples have too much difference on their mean to assume that it's representative of all smart cities of the world, which made kind of sense, by the way, because yes, cities are different. But then, since I'm using these computer simulations, by using the data, the empirical data collected on the cities, on the case studies, so I'm then running a model with lots of randomness, and I'm then making a better inference or generalization towards all smart cities, since yeah, this model are simulating random interactions, so it can basically represent any cities in the world. That would be my answer. Yeah.
Cool. Cool. This is great. Do you plan to pilot a particular application with your analysis?
Basically, I would love that. So for my next step for the future is that I'm using that book as a hook to catch some opportunities, to join some teams of urban developers or data analysts working on urban innovation. And then, so I would like to run my analysis on some more case studies. So basically, it means like, yeah, collecting more data by myself, or partnering with some city or company which already have data on different cities. So that would be a way to refine my models. And so basically, these models are now the prototype of a data app. So of course, it's very, let's say, it's a backend. It's written in code. So I would like to make a user-friendly interface for people which are not coders to be able to use to run my models with no code. I mean, basically just clicking on some boxes and saying, okay, so my city is this one, and I want to collect information, let's say from Google News and Facebook feeds. And then, so yeah, you choose your inputs, and then in the middle, you choose what kind of reports you want to have on your city. And so you will select a kind of template, and then poof, you have like after some time, you will receive like, you can automate reports on your city or around your urban innovation startup. So that's basically what I'm targeting, and what I will be working on for the next months is web data app.
That's awesome. Best of luck for your new book, and this is awesome. Yeah, I guess citizen engagement and political engagement, apathy, these are super critical and drives the economy hugely. So thank you so much for your work.